Hello everyone and welcome back to another video. In this one we are going to discuss about Poisson distribution. So Poisson distribution occurs when an event occurs over a fixed period of time. Just want to be clear here that it's not necessarily always time, okay? It can be in a particular area over a particular volume, so it could be anything. But for now, let's consider this as the definition. So when an event occurs over a fixed period of time at a constant rate. Okay, so we are going to also discuss about this constant rate. For now, let's say it is lambda. Okay, and obviously the outcomes are discrete. We are discussing about discrete distribution, so it will always be an integer value. It can never be decimal points. Okay, so for example, the number of arrivals at a cafe. Okay, so at a particular place, the number of arrivals that are occurring, or the number of calls that are occurring in a call center every hour. Okay, so that is when Poisson distribution comes into the picture. All right, so we are going to define the PMF, which is the probability mass function, or we call it f of x, as e to the power minus lambda. So lambda here is our rate, okay, the rate at which things are occurring, into lambda to the power of x upon x factorial. So x is the success rate that we are talking about, the success number that we are talking about. Okay, so now let's define the mean or the expectation. So it is nothing but summation of x into f of x, right? And here our f of x is, so our expectation is nothing but summation of x into f of x. All right, so f of x is e to the power minus lambda, lambda to the power x upon x factorial, right? So we can take the constant out of the picture. If we do that, we have e to the power minus lambda out, and we take one of the lambdas out as well. So we are left with lambda to the power of x minus 1, right? And if we open this up, if we open this x factorial, we will have this as x into x minus 1 factorial. So we cancel these two x and we have just this left. And if we open up and start putting values of x, we'll have, so first we put x is equal to 1, we get 1. We put x is equal to 2, we have lambda upon 1 factorial, and so on. So if you know, this entire thing is nothing but e to the power of lambda. Okay, this is a particular okay, so lambda e to the power minus lambda into e to the power lambda, we get it as lambda. So this is your expected value of x. Also, the variance of x is same. We are not going to discuss the derivation here. If you want, we will provide the link in the description box. And moving ahead, if we talk about this example, so let's say we have an example in which we say that a given traffic light is run over an average rate of 5 times per month. Okay, so 5 times per month when they say, so our lambda will be 5. Okay, lambda is always the rate. Okay, and x is the success time that we are talking about, the number of successes. Okay, so find the probability that the light is run 8 times on any given month. Okay, so x becomes 8, lambda becomes 5, and we have to find the probability. Okay, so we use the PMF that we have. So probability that x is equal to 8. So our PMF was e to the power minus lambda, lambda to the power x upon x factorial. So we simply use these values and put it here. Okay, so we get e to the power of minus lambda, which is minus 5, lambda to the power of x upon x factorial. All right, and on solving we get 0.0653. So there is 6% chance that the light is run over 8 times on any given month. Okay, now next is find the probability that the light is run at least 3 times. So at least 3 times or more. Okay, So whenever we talk about at least 3 times, what we do is we say, so basically it says that probability that x is greater than 3. Okay, at least 3 means 3 or more. Okay, let me clear that. At least 3, it actually means 3 or more. So we have probability x is greater than 3, which is same as probability 1 minus probability that x is less than equal to 2, right? So greater than 3 or 1 minus it is less than or equal to 2. So we use that and we get it as 1 minus probability that x is 0, probability x is 1 and probability x is 2. Okay, so this is what we use, and when we put on the values of these, we finally get this as our answer. So this is the probability 0.87. Okay, which says that 87% chance. Okay, 87% chance that the light is run at least 3 times on any given month. So I hope this was clear. If you have any questions, please feel free to ask in the comment section. Thank you for watching.